What's going on, everybody, and welcome to part 3 of the self-driving cars with Carla tutorials. In this tutorial and the coming probably at least like 2 plus more, we're going to be talking about doing reinforcement learning, specifically deep Q learning with the Carla environment. Now, to do this, we kind of have to change the architecture a little bit of how we're approaching this problem. We want to approach this problem with the with everything being set up to work well with the concept of reinforcement learning. So there's a million ways that we could do this, but with the advent, basically, or the introduction of OpenAI into the world, now known as closed AI, they had kind of set the standard for how to approach and work with environments to do reinforcement learning, and that methodology kind of has persisted, and it tends to be how everybody handles reinforcement learning, whether or not they're actually using the OpenAI environments themselves, like Gym or Retro, or now maybe is the name, and I forget the other one, but like Atari maybe? Anyway, not important, but basically you want to have some sort of environment that has a couple of methods. So we're going to basically keep all this code here. We're going to have to get rid of a lot of stuff because we can't really run this as a script anymore. We probably use object-oriented programming. So we are probably done with all of this. I do kind of want to leave process image. We're going to just convert that to a method rather than a function, but that's okay. In width and the height, we'll probably end up moving those, so I'm just going to delete those. Mostly I just want this block of text. I'm determined to never write it. Anyway, basically the standard for reinforcement learning environments is to have some sort of .step method for the environment where you pass an action to that step. And maybe if the syntax was working, it would look better. So anyways, you'll have some sort of step method where you pass action. You'll do something with that action and then collect any information, like determine what the reward was and stuff like that. And then when you're done, you return the next observation, the reward, whether or not we are done. So this will be like a flag. It'll be a Boolean flag, basically. So this will be true or false, whether or not we've either reached the end of the environment, like we were successful in what we tried to do, or we ran out of time, or we died for whatever reason. So, and then finally, usually it's just, you see it as an underscore, but it's just extra info. So if there happens to be extra info, this just, again, just kind of the standard. We generally almost always care about observation, reward, and whether or not things are done. But any environment, we tend to throw this in. That way, and the reason why we want to use this standard and continue to use this standard is there are different reinforcement learning models, basically, that you can work with. And whether someone did it with, OpenAI Gym, or they did some other environment or whatever, you can easily just swap these models around to all kinds of different environments. And some environments might want to return some extra info for who knows why, but maybe. And we just leave that there so that is possible. So some sort of extensibility is possible. But anyways, this is what we want to do. So we need a step method, and then we also want a reset method. And this is either at the very, very beginning of the environment or after we've returned a done flag. If we want to run another episode, so to speak, we'll reset and run another episode. Okay, so that's what we want to do. Now what we need to do is actually do it. So what I'm going to do is just come down. Again, I'm just going to leave this process image code here because I'm going to pretty much need it. I'm just going to add a bunch of self dot in front of everything. So I'm going to leave that there. But we're going to start some new code here. And the first thing I'm going to do is we're going to, at the top of this script, we're going to have a bunch of like starting variables and constants. But for now, I'll just have show preview. And I'm going to set that to be false for now. And this is whether or not we want to display the actual camera from Carla. So you wouldn't want to always display it. One, if you have a worthy machine, you'd want to run many agents at the same time. But two, displaying that preview is going to hog up computing resources, both CPU and or GPU. I believe OpenCV purely uses CPU, so it's going to lock up CPU. But it's going to use resources nonetheless, and probably we're going to be maxing things out, so we'd rather not. But if we want to use it for debugging purposes, we can turn this flag to true just to see a couple of previews and then turn it back off maybe, or whatever. Anyway, I'm going to set it to false for now, but you definitely would want to be able to see what's happening sometimes. So then we're going to have class, and we're going to call this car environment. And now I'm going to just set some of our initial values. So first we're going to have show cam, and for now that'll just equal show preview. We might also have show cam show every, even if show preview is set to true, maybe it shows every, I don't know, 10,000 episodes or some, not 10,000 episodes, a big number, 100 episodes or something like that. So show cam equals show preview for now. Then we're going to have steer underscore amount. We're going to set that to 1.0. Basically, we're going to fully, there's 3 actions we can take. It'll be a 0, 1, or a 2. So we can either, or actually it'll be -1, 0, or 1. And basically we can either steer fully left, go straight, or steer fully right. But later you might want to make this maybe cumulative, so the steering wheel slowly turns one way, and then if you want to go the other way, you slowly turn the other way. Depending on what kind of frames per second we get, we could probably do some much more fancy stuff there. But for now, we're just going to do full turns every single time. Then what we're going to say is we're going to throw in an im, and in fact, I guess we'll just toss this up here. So im underscore width. I totally just deleted all this stuff. Width 640, im height 480. I was wondering how that was getting typed in there. And okay, I see now. Cool. So we've got those, and then for now, I guess we can set those to be equal to these as well. So im underscore width. Im width we'll set equal to im width, and then im height, im underscore height we'll set to im height. Okay, so then what we're going to do is we are going to, I think we'll say front underscore camera for now. We'll say that's none, and I think that's it. That's all of our basically initial values that we want to set. Now what we're going to do is we're going to define init, and we'll say self here. And what we're going to say is basically all that starting, I deleted it, but the starting code to connect, it's not too much anyway. So we need to connect to the server. So self.client is going to be carla.client. And then we're going to connect localhost port 2000. Self.client.set underscore timeout. We're going to set that to be 2 seconds still. Self.world is equal to self.client.get underscore world. Blueprint underscore library equals self.world.get underscore blueprint underscore library. So, okay, we've got the blueprint library. Now we want to grab our car. So self.model underscore 3 is equal to blueprint library.filter, and we're going to filter for model 3. Actually, it's just model 3, no underscore there. And then the 0th index. So with that, we probably have everything we need when we first initialize, because we just want to have access to our blueprint library. We want to, well, at least in this case, we just grab for the car. In fact, we might even, I think we'll just make this self.blueprint library, because we're going to probably need to access that elsewhere, because we need the sensors as well. So I'll just do self.blueprint library. Okay, so with that, we're ready to do our reset method. So we're going to say define reset, and again, Here, just pass self. There's nothing that needs to be passed. Step is what's going to take in the action. So at the beginning of every reset environment, what do we need? Well, we're going to say self.collision_history. That'll be an empty list because the collision sensor returns a list of these like collision events. Basically, if we have any collision event, we're going to go ahead and reset. At least that's what we're going to do to start. Later, I might customize that. I haven't looked too deeply into the collision sensor. The collision sensor basically reports like some sort of like magnitude value. And sometimes like if you just drive over like a pretty non-substantial curb even, like you're totally fine. Even though that would in theory probably throw the car out of alignment, it says that was a collision. And I've even seen it call a collision like if you just simply like go uphill really quickly. Like maybe the bumper scraped the floor or the ground because you went too fast. I'm not really sure, but I've seen it register that as a collision as well. So we might want to require the magnitude to be higher than anything, right? But for now, if anything is in this list, so if any collision is detected, we're just going to say, hey, you failed. And then self.actor_list is also going to be an empty list. And again, we just always want to track actors so we can clean them up at the end. So then we're going to say self.transform equals random.choice self.world.get_map.get spawn points. Okay, don't forget your open and close. That's a method, get map, and then get spawn points again, method. Okay, so we've got the transform. Now what we're going to do is self.vehicle equals self.world.spawn_actor. And we want to spawn self.that model 3 from above. And then we're going to spawn it to self.transform. So we've just spawned an actor. What do we need to do? We need to self.actor_list.append self.vehicle. Okay, so now that we've done that, we want to get our RGB camera. So that's the next thing I'm going to go ahead and add. So we're going to say self.rgb_cam equals self, we're going to use blueprint library. So self.blueprint library. And then we're going to say .find and then sensor.camera.rgb. Secretly actually an RGB alpha camera. self.rgbcam.set_attribute, and we're going to say image_size_x is the f string of self.imwidth width. Cool. And then what I'm going to do is copy this, paste. We'll do 3 pastes. So so then y. So you've got your x, your y is your height. M height. And then this will be field of view. And then we're going to I'm just going to hard code this to be 110 for now. Okay, so just like our vehicle, we get the vehicle. What do we need to do? Well, we need to specify the transform. So I'm just going to say transform equals Carla.transform. That's a capital T. Did I transform? Transform equals Carla. Did I do a where's the other transform? Okay. I don't really see it. Anyway, Carla capital T transform. I'm just curious why it wanted to lowercase that t, but I'm sure when we go to run this, we'll see errors. So, and then Carla the current location, and this is again, I believe, to be a relative position. So it's just in relative to where we throw it. We want to move this. So transform. Then what we want to say is the self.sensor is equal to self.world.spawn_actor self.rgb_cam, so it spawns the actor, and then transform, and then attach _2 equals self.vehicle. So now we've got this camera on the front of our car. We've got a new actor. What do? Well, we append to the actor list. So copy, paste, and in this case, it's not self.vehicle, it is self.sensor. So once we've done that, the next thing we want to do is we want to say self.sensor.listen, and we'll do lambda for, lambda data, and then self.process_image data. Lambda data. What have I done? Oh, okay. Lambda data self.process image data. Okay, so then we need to we need to convert this to be a method inside of our environment, which we will do. I'm just going to go ahead and finish what we're doing here, and then we can do that pretty quickly. So once we've done that, we've got our car, we've spawned the car. We've got our camera, we've spawned the camera. So we've got all that, and whenever you create this car and you spawn a car, I don't know why they did this, but they did. Thanks, Carla people. When you spawn a car, it actually falls from the sky. And maybe they did that because that was the easiest way to overcome issues where you spawned and were clipping a little bit, like your tires maybe were clipping and you couldn't move. I don't know. I'm sure there's a great reason for it, but you fall from the sky. And when you fall from the sky, one issue is you actually can't drive yet. The other issue is when you hit the ground, sometimes the collision sensor registers that as a collision because you just fell from the sky. And then also, initially, your RGB camera hasn't yet, I don't know if it initializes or what, but it doesn't actually start pulling in data. So sometimes, as soon as you try to grab imagery from the RGB camera, you cannot. It just returns none. And this is for a variable amount of time. I couldn't figure out, or like sometimes it would immediately return imagery, and then other times it would take some time. Don't know why, but it's a thing. So we have to handle for that sort of nonsense occurring. So we're listening. Then what we're going to say is self.vehicle.apply_control. Yes. So I left out one more thing too, is that the duration that it takes for the car to actually start doing things also is variable. So like the camera, they're just weird things that happen. And I didn't really discover this. Daniel seemed to discover that if you just apply some control, like even if you don't do anything, if you just send in the command to control, it makes the car react more quickly. Anyway, so I'm going to throw this in. I have no words. Anyways, Carla you already know how to do vehicle control, so we're just going to say throttle equals, and we're going to say 0.0, and then brake equals 0.0. Definitely more research is required here to figure out exactly how to feed Carla what it wants to make it act as quickly as possible, because the speed that we can run through episodes, the faster we can do that, the faster we can train these models. So it's really important that we can get this thing to just get going like as quickly as possible. So we'll have to just continue to work to try to figure out how to make it go as quickly as possible. For now, time.sleep 4 seconds. So considering the fact that episodes are going to be about 10 seconds, a full sleep of 4 seconds on top of those 10-second episodes stinks. I really wish we could get things rolling a little quicker. So anyway, Carla people, if you're listening, which you're not, I'm sure, but if you were, how can we do this quicker? Anyway, now we've got the car, we've spawned the car, we've wiggled the car. Well, we haven't wiggled, but we've sent some commands, so hopefully the car's paying attention now. The last thing that we want to do is we're going to do the collision sensor. Call sensor equals self dot, what was it? Blueprint library? Yeah. Self.blueprint library.find, and we are going to attach the sensor.other.collision. Great. So that's our collision sensor. The next thing that we want to do is self.callSensor is equal to self.world.spawn_actor, and we're going to spawn call sensor, transform, and then we're going to attach _to equals self.vehicle. vehicle. As I write this, I wonder if transform even matters. Like I would almost assume you wouldn't need to. Like I don't think this is going to matter that we've added this collision sensor here. I just kind of realized that we were doing that. Anyway, the collision sensor works like that, so I'm going to leave it. But you probably don't have to adjust it, but we're just going to reuse transform. Okay, so we've spawned an actor. What do we need to do? You guys know the deal. So we need to self.actorlist.append call sensor. Cool. Okay, so now that we've done that, we want to we're going to say self.callSensor.listen, and again we're going to lambda. We'll say event this time. Self.collision_data event. So now we need this collision. We'll also need the collision data method, but again, that's a really simple one. And then in order for this agent to run, like basically we're done at this point, but in order for this agent to actually run, it has to return an observation. Well, our observation is the front-facing camera. So if after 4 seconds that camera still is not ready, we are going to say while self.front camera is none. So it returns none until it starts returning things. We're going to say time.sleep 0.01. Now we could possibly like do all the handling for sensors and maybe a few other bits of information and then comment this out. That way we're doing the least amount of waiting possible. So yeah, there's definitely much more optimization that we can do here. But for now, we're going to follow up with this. We just want to make sure things work first. And then we can start to optimize other things. But anyway, we'll do that. Once that's done, it means the episode actually has started. So we're going to say self.episode_start equals time.time. Because we want to run episodes for 10 seconds. Otherwise, we would just pretty much run infinitely. So yeah, I think we're just going to say episodes are 10 seconds fixed. We could later maybe even remove episode time so the longer it runs. But the problem is agents will sometimes find things that they can do that you didn't expect them to figure out. So for example, they might find that they can drive in circles. Like that was one of the things that we discovered. And they'll just do that infinitely long. So sometimes it can be better to actually end it at some point. But when it's first starting out, I mean, it's going to crash constantly. So you might not even really need to worry about this. But anyways, we're going to track episode length anyway. Self-episodes. Okay, so then we're going to issue one more of these self-vehicle controls. Again, it just seemed like throwing these at Carla could get things running. I really don't. We have no definitive testable findings here yet. We're trying to figure out how we can get things to just work quicker. But yeah, I mean, if you're just trying to run a car one time, you almost don't even notice the issues. But when you're trying to run 100,000 plus episodes, you start realizing, there's strange things happening here. So anyway, self-vehicle apply control. Great. And then we will return self.front_camera. Okay, so we've done that. Now we need to add those two methods below here. So self.camera. So we're going to say define collision_data. And this will be self. And then it takes an event. And then what we'll do here is we'll just say self.collision_hist.append any event. So if we have an event, we'll just append it to the history, and then we'll handle for this in the actual step method. And then we need our process image method. So now I'm going to take this, cut, move it up here, pasta. Hey, I don't appreciate this. Thank you. So process image will pass self image I equals blah 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 blah. If we'll pass here if self.show cam, I want to say, yeah, show cam. So if self.showCam, we will show the camera. Dude, you were killing me. Okay. Oh, and then we need to fix this. which will be self.mWidth, self.mHeight, or actually height and then width. See, I tried to make that mistake. I told you that was going to happen. Height, maybe I'm just stupid. Self.mWidth, or both. mWidth, can't rule that one out. Okay, I think. Here, what we want to do, if self.showCam. So, we'll just do this. We'll say self.front_camera equals I3. And then we'll just have to remember to scale that down with the negative, or divided by 255. We'll do that at the end. Okay, I think that's good. I'm sure I've got problems, but I think we're good there. So now the last thing we need to do is the step method. Well, it's not the last thing, but the last thing we need to do for our Carla environment. I was tempted to do that in the next video, but I think we'll just throw that in really, really quickly because that's pretty basic. So define step, and then we'll pass self action. So basically it takes in a specific action. And then we're going to have if action, yeah, I totally misspoke. If action is equal to 0, we'll pass, and then we're basically going to elif action equals 1, and then we're not actually going to pass, but elif, and then else. Actually, I'd rather this be an elif action equals 2. Pass. So if the actions, so we're going to say the actions are 0, 1, and 2. Yeah, we wouldn't want to do -1, 1, and 1. We'd rather these be like argmaxes of output. So 0, 1, 2. So 0 is basically the left, 1 will be go straight, and then 2, let's say turn right. So if action is 0, we're going to say self.vehicle.apply control. And then it's Carla.vehicle control. And then we're going to say every time the throttle, we're going to set that to full throttle. And then we're going to say steer is equal to -1 times self.steer amount. So this should say -1 times 1, right? So steer will be a -1. And then, because again, later we might change steer amount to do other things. So for now, this will be fine. So that will be go left. Then this will be go straight, and then this one will be go right. So rather than -1, it will be 1. And then here, in theory, you would say 0 times steer amount, but I'm just going to put in a 0 just for easy legibility's sake. Okay, then basically you could say as this thing goes on, you could you basically, if it's not colliding with something, you could give it a reward. But instead what we're going to do is I'm going to use speed only because I know the car will figure out to just drive in circles, and we don't want that. So we're going to say v for velocity equals self.vehicle.get_velocity. And then because velocity is not really super useful, we're going to convert that to kilometers per hour. And we're going to say equals the int value of 3.6 times math.square root. I might not have imported math by now, but that's okay. Of the velocity x squared, hey bro, plus velocity y squared plus velocity z. To the power 2. Okay. Cool. So that should be our kilometers per hour. And I don't think I imported math. I'm sure that's why it's angry. Yeah. So let's go ahead and go up here. Import math. And then we'll go back down to the bottom. And okay. So then what we're going to say is if the len of self.collision history does not equal 0. Like later, we could do something much more fancy with the events that exist in the collision history. But right now, if we've registered any collisions, we're going to say done is equal to true. And then we're going to set the reward equal to -200. Again, I'm just pulling these numbers out of nowhere. You might want to make that penalty basically much larger, maybe -500, -1,000. You know, I don't know. I really don't. I'm just making it up as I go. So if kilometers per hour is less than 50, then what we're going to say is done equals false. We're still running. Everything's happy. And instead we're going to say reward is equal to -1. So any steps that we take, any frames that go when we have not, we're not going faster than 50 kilometers per hour, which honestly is not very fast. But I used 50 because to reach 50 kilometers per hour just driving in a circle is kind of hard. So that's why I went with 50. Again, just kind of making it up as I go. So it'll be -1, but we didn't crash, so it doesn't need to be a huge penalty. Again, you also could set this to be 0. I don't know the answer to that. We have to research it to find out. Else, we're going to say done equals false and the reward equals 1. So if it is above 50, then we'll keep appending 1 to the total reward. Okay, so that's basically, we've got our actions handled here. We've got our calculation for reward, but the other thing we want to do is we want to limit the lengths of these episodes. So we're going to say if self.episode_start plus seconds, we'll do seconds per episode. So probably to start, we'll just say 10 seconds. So we can come up to the tippity top here. We can say seconds per episode. We want 10-second episodes. If plus seconds per second is less than time.time, then what we're going to say here is done equals true. Cool. So then finally, the last thing that we're going to do here is return self.front_camera. So observation, reward, done, and then for now, none. We don't have any extra information that we want to pass. Okay, I think I'm happy with that. I'm sure I've got issues here, so stay tuned to when we actually run all of this stuff to fix any errors. If you see something, feel free to comment below, but I'll find it out. We've also written a lot of code here, so right now I don't have the text-based version of this tutorial up yet, but by the time you see it, it probably will be up. So I'll have links in the description to that. So if you want to make sure your code is the same or whatever, feel free to do that. With that, shouts out to my channel members. These are people with me for 1 month: Carter, Babin, Blackhawk, 3003, Jesse Jones, Payne, Max, Philip Wagner, not Brian Bradley, and Visarad Kumar. Thank you all very much for your support. You guys are amazing individuals. Okay, questions, comments, concerns, whatever, feel free to leave them below. Come hang out with us in the Discord. That's discord.gg/Sentex. If you want to support the channel, you can click that beautiful blue join button. Otherwise, that's it for now. I will see you guys in the next video where we will be working on the agent itself. And then hopefully after that, we can bring everything together and actually start running the agent. But it's going to take a long time to do the learning. Okay, see you guys then.